Perfect. 8.5 is the last section in Unit 8. There really is no additional concepts that you need to know. 8.1 is the hardest lesson because it has the most amount of rules to learn. And 8.2 kind of went into those fractional exponents. And then 8.3 and 8.4 just kind of wanted to see what you could do with it. But 8.5, there's really no additional work except you really have to know the difference between these two words, rational and irrational. When I looked at your worksheet, there was basically two halves of the worksheet. The very first 18 problems you were going to have to work out, and then you have to decide, is it rational or irrational? But that's only level 1 type of stuff that you need to know. The level, then jumps, in my opinion, from level 1 to about level 3. Like it skips level 2. When you get to questions numbers 19 through 25 on this worksheet, it's going to ask you to come up with examples or counterexamples to really find out, do you know what we're talking about on the previous page? As a matter of fact, your worksheet on numbers 19 through 25 is going to ask you to make a conjecture. And some of you don't know what that word means. The word conjecture means a mathematical hypothesis. So I had you write that down because I want you to know when it says, hey, come up with a conjecture about what you're reading. I want you to come up with a mathematical hypothesis, a guess, a mathematical guess of something that you think is true, that works for all situations. Not something that would just work for one situation, something that would work for everything. Okay? So I have several examples here from the first half of the worksheet. You're going to be doing them, and then you circle R or IR. And then we have the ones that, in my opinion, are like, ooh, a couple levels harder. We'll talk about those in just a little bit. So let's go back to the beginning. What is a rational number? A rational number, by definition, is a number that ends or that is a repeating decimal. It's something that can be written as a fraction. So I have several rational numbers here that you could look at. The number 1 is rational. The number 2 is rational. -3, rational. Same with 0, as a matter of fact. 0 is rational. 1/3, rational. Even the square root of 4 is a rational number because the square root of 4 simplifies to 2. Those are rational numbers. Irrational numbers are numbers that never repeat themselves and they go on forever. For example, the square root of 2 is irrational. The square root of 3 is irrational. -2 times the third root of 5 is irrational. 1 plus the square root of 2 is irrational. Anything that doesn't simplify to a whole number that's inside a radical is going to be considered irrational. And that's our major idea here. Not to really know the ones that simplify, the ones that can be written as fractions or whole numbers are rational, whereas the ones that are inside radicals that don't simplify are irrational. And if we know that, and we know what we did from 8.4, we should be fine on doing the worksheet. Because it's really a review worksheet. It's what it is. Let's look at what some of the examples are. 2 root 5 plus 6 root 5. This is number 2 on your worksheet. 2 root 5 plus 6 root 5. They want you to figure out, what is that? What does that equal? And I'm hoping you know, when you're adding or subtracting radicals, the same roots with the same insides, meaning the square root of 5 and the square root of 5. All we do is add or subtract the coefficients while leaving the roots the same. Like that's what I wrote to you as a reminder. 2 root 5 plus 6 root 5. You can only put root 5s together with other root 5s. How many would you have? You would have 8 root 5. as your answer. And then you have to decide, is it rational or irrational? Well, root 5 doesn't simplify. Root 5 would be this decimal that doesn't repeat itself. It is irrational. My next example is number 7. Now, when you have parentheses, if there's something in front of the parentheses, it means multiply it by it. There's nothing in front. If you have an exponent outside of the parentheses, it means you have to deal with that exponent, and that's how many factors you have. There's no exponent. The only thing that we have here, so this right here, because there's nothing in front and no exponent, you can drop the parentheses. There's no reason to have them. It's the same thing as 3 plus 7 root 2. This second group, though, you are subtracting the whole group. Because you are subtracting the whole group, those parentheses make a difference. The first thing you would have to do before you move the parentheses, let me erase that second one. That just does not go well with me. There we go. We need to take this subtraction sign and we need to subtract both of these two terms. I need to subtract the negative 5, which would make add 5. And then I need to subtract the plus 7 root 2. So I'm going to subtract 7 root 2. It just changes the sign. We're doing the opposite of. Now, once you subtract that group, now you can combine your like terms. You can only put root 2's together with other root 2's. 7 root 2 minus 7 root 2. Let me look at that. 7 root 2 take away 7 root 2. That makes 0 root 2. 0 times anything makes 0. It makes it cancel out. So what's left? 3 plus 5. What is 3 plus 5? Now I know this one started off as irrational. But now that we have put things together and these have gone away and it simplifies to 8, is it rational or irrational now? It is now rational. What they are trying to get you to realize is that the sum of irrational numbers or the difference of irrational numbers sometimes might be rational. Here's an example of where something started off as irrational. When you had putting them together, adding them or subtracting them, you can get a rational value. My last example from the first half of the worksheet is number 12. Negative 2 root 5 times 7 root 3. When you're multiplying your rational numbers, insides multiply insides and outsides multiply outsides. What does that mean? That means that these are on the outside. They multiply each other. Insides would multiply the insides of the radicals. Root 5 times root 3. There's no pair. It doesn't break down to anything. So you have a 5 inside and a 3. 5 times 3 is 15. And there's really no pairs there. So you just put them together. Put it as negative 14 root 15. And then you decide, is it rational or irrational? When we multiply two rational numbers, sometimes it's irrational. Just kind of ideas. They're trying to get you to start seeing things in terms of all irrational and all rational numbers. So then they ask you the next level questions. Based on the work you completed in problems 1 through 18, make a conjecture. That's that fancy word for a mathematical hypothesis to answer the following. What can you say about the product of any two rational numbers? So I'm going to give you a couple examples. of any two rational numbers. Think of some rational numbers. The 8 was a rational number. 2 was a rational number. 5 was a rational number. -1 was a rational number. What can I say about the product when you multiply any two rational numbers? Think of this one times this one, or that one times that one. We could even multiply that one. Any two rational numbers, think of all the possibilities. That's a lot to think about. Let's think about 5 possibilities instead. What do I know about the product of any two rational numbers? A nice general statement. What's this times this? What's this times this? We don't want to say what each individual answer is. We got to make a generality about the whole thing. What can you say about it? Any ideas? I'm going to give you a little bit of a hint. It has something to do with the word rational or irrational. What do you know about all the products? This times this, and this times this, and this times this, and this times this, and that times that, and that times that. They will all be what? Go ahead and say it out loud. Okay. They will be rational. I like it. It's a good conjecture, good mathematical hypothesis. That's a great fancy word. You want to impress your friends? Say conjecture, or they just might look at you and laugh at you for a little bit. I'm not sure. Depends who your friends are. Lastly, this is my last example for you, and then I'm going to give you some time to work on your worksheet. It's number 23. It says, can the sum of two irrational numbers be rational? Can the sum of two irrational numbers? So think about this. If you think about irrational numbers like the square root of 2 and the square root of 3, you may not see this right away, because you cannot add the square root of 2 plus the square root of 3. They're not the same insides. Can I add them and have it to be rational? Let me think about it. Let me think about a different example. Maybe one that we used up here. Remember how this one here was irrational, and we subtracted this irrational, and something happened to where we got a rational value. What did they do? They got something to where there was a rational number and then a negative rational number the same way, to get those to cancel out. So for example, let me think about it. I can't do these kind of rational numbers. Let's say not these ones. These don't work. But what if we had something like 2 square root of 2 plus 3, and we were to subtract the square root of 2? Let's just do something really simple like that. Okay, first and foremost, irrational, because the square root of 2 doesn't simplify. Whole number. Together, they're irrational. And if we, the sum. We need the sum, right? So let's add a negative root 2. Now we have a sum. Square root of 2 plus 3. We're going to have a sum with this negative root 2. What's going to happen with the positive root 2 and the negative root 2? Which would make 3, which would turn it into a rational number. Matter of fact, anything that had a positive radical being added to the negative radical starts making a rational number. So the answer to this is yes. Gave an example. Here are 2 examples that would work for you. Something with a positive root 2 and a negative root 2, or a negative root 7 and a positive root 7. They would create a rational result. I'm going to stop your notes right there.